Hey guys, this is Jeff from Tech Shop Talk, and today we're going to be talking about the continuity test. Now, the reason you might want to do a continuity test is you may have put wires in your bus or in your van, and put those wires in, and then you went back and put in different types of materials, to cover the roof and the walls and stuff like that. And so you want to just test and make sure those wires are still good. So what you can do is a simple continuity test. I'm going to show you 3 ways of doing this. And all 3 ways are pretty simple, fairly simple. Now, whenever you're checking continuity on a wire, make sure that that wire is not connected to power, a source of power, or any type of circuitry in between the areas that you're checking for continuity. It is best to have your wires not touching anything or not connected to anything whenever you're testing them. Okay, so the 3 ways that we want to talk about doing continuity test here. One is going to be just using a tone, which is we're just going to actually use this meter right here. I'm going to set it for tone. If I take these 2 leads and put them together, you'll hear a tone coming from the meter. Now, most meters don't have tones, so the other thing that you can use is you can use a lighted, instead of a tone, a light. So if I turn this one on and I put the two leads together, you'll see that there's a green light that comes on. See, it's off, it's on. So that's another way to do the test, to test the wires, and I'm going to show you how to do that. And the third way is let's just say I've got this little inexpensive meter here, which I'm sure many of you may have. If you're working on electrical systems, I suggest that you get a meter. You're going to put this on the ohms part of the meter, which right here I've got several of them, but you may only have like a 1K and 2K, or 1000 and 2000 is what that is. I'm just going to set mine on 2000. So when I put, right now, as you see that it's showing a 1 in that screen, let you make sure you're seeing it. If I take the 2 leads and touch them together, you'll notice that that turns into a 0. Now, anything other than 0 on this meter, so if it just shows you a 1, right, then it's open. We consider that open, which means that you don't have continuity there. If it shows you any reading other than 1, but not 0, that will mean that you have some kind of problem with the wire. Sometimes corrosion can cause the wire to not give you the correct ohm reading. Sometimes, if it's just touching another wire, you may get a different reading than that. But basically, you want that 0 reading on the ohms. If it's just the 1, it means you either don't have the same wire, or else it's open, it's cut somewhere in the line. Okay, so let's take a wire, and we're going to do this. So right here, this is a little 4-conductor wire. You can't see that because it's blurry, sorry. But it's got 4 wires in one. It's a 22 gauge. It's something that that's used a lot with low voltage. And you're going to see the red, black, green, and white here. But the only thing I have on the other end is going to be the white and the green. So there's a couple ways that we can do this when we're testing it. So I'm going to go ahead and I'm going to take this wire and we're going to cut that off, so we actually have bare wire on this. So if I was testing this thing could be a long way away. As long as I can get a reading, from both ends of the wire, then I'm good. So let's say this wire was 100 feet away from me. How would I test the wire? Now, I know that these 2 wires aren't connected to anything. So what I can do is I can twist the white and the green together right here. And then when I'm doing my test, I'm going to test the wires, right, with the white and green. So I'm getting a test on that. So then what I'm going to do is I'm going to take these wires apart. So I know that they've got continuity on them, and apart I get nothing. All right. So again, if I was doing this with the light, let me twist these wires back together. Right. If I was doing it with a light, I'd set my light, put one of these clamps on the green wire and one of these clamps on the white wire, and then I'd look for the light, and you see the light's on. Pull it off, the light goes off. So that's a way to test it with a light. Now this block right here, where do you get one of these? This is actually a tone generator. It goes with an inductive amplifier, and one of the functions on this one is that it does have that little light meter that's in it, where it will actually test for a good wire. So that would tell me that those two wires are good. Well, these two wires aren't connected at the end. Let's say both of the red and the black are here, but we have them twisted together. But of course, they're obviously cut, somewhere. If I were to put my leads on there and test it for continuity, of course, it's not going to light up because it's not connected, and they're just cut off. They're inside the wire here. So that's what if you were testing a bunch of wires and you found out just going through each wire, kind of doing a twisted pair because they're 30 feet away, you can test that to see if those wires have continuity. Now, does that tell you that those wires are good? It doesn't. It doesn't tell you that those wires are good. It just says that, hey, you're getting continuity. But what if you were actually getting continuity from the middle part of the wire? Because in here, the two wires were touching, which wouldn't happen generally in this. But let's say you had several junction boxes, and one of the twists, where the wires were either soldered together, was touching the other group of wires, and you would actually get continuity there. Okay, so I've shown you 3 ways to do the continuity test. Now the continuity test, you have to know, whenever you're doing a continuity test, you have to know that your wire is not connected to anything like your battery. You don't want it connected to circuitry. You're not trying to run a continuity test through what we call a circuit. So basically you need to know 2 ends of the wires, and nothing else is supposed to be connected to those wires. And then you can test it, do the continuity test, which basically is just telling you that the wire is good and that it's not broken in the middle, or if you do the ohms test, that it's not grounded anywhere. So that's what the continuity test does. Now I mentioned this guy right here, which is a signal generator. Now a signal generator, I'm just going to give you this as a little extra. A signal generator, what it does is it sends out a signal like it's a tone is what it's actually sending through there, which is basically a frequency, and this one is just jumping between 2 frequencies. With a wire, let's say that this was strung out, this wire was strung out maybe 30 feet, through walls and everything else, but you're trying to find out where this wire is, where it goes, that type of thing. So if I and I only need one of the leads on here, because the signal is just sending like if it was on an antenna, like if it was a radio. And let's say this was on the other side. Let's undo the 2 wires here. This is an inductive amplifier. So you're going to be looking, if you're looking for this, if you've got to find a wire that's strung through a bus, or if you're going through that large, massive mound of wires that we were talking about, where you're removing wires out of the system, because there's 30 wires going through the wall, back to the back of the bus, or into the interior of the van, and you needed to find a single wire out of that. So you would actually hook this to, let's say you go to the alarm connector for your bus door. You want to find that wire. You're going to remove that wire. So you could use this. This is like I said, you can get this for under $20 at Amazon. It may not be what you need, but it is available if you have a use for something like this. But basically, this is an inductive amplifier. So when I put it up against the wire that is sending out the tone like a radio, and I press a button, you hear that. Now, the farther I get away from the wire, then the closer I get to the wire. So let's just say we were looking for this wire, and it was strung out through the wall and everything. I could go through the wall, and everywhere where I hear this wire. So basically with this thing, you could follow it and look and go all the way down the wall, and you could hear where that wire is actually at. So this isn't really going to be a continuity test thing, but if you were searching for a wire and you wanted to know where that wire was in the wall and the ceiling, you could actually use that right there to actually track that wire down. One of the things I've noticed that in these bus builds that people are doing is the wires that go from the front of the bus all the way to the back of the bus, they go through those, and every wire that's not going to be used, they remove that wire. Which is absolutely fine. I mean, you may never ever need another wire to go back there, but as a rule of thumb, as a technician, one of the things that we do is we don't remove all the wires. I mean, if 15 wires going to the back and I only need 6, I'm going to leave 9. I'm going to make sure that I have 3 extra spare wires. What happens if in like a house, which it's actually could happen in a bus also, let's say a rat gets into your wiring and chews through one of your wires. Well, you've got 3 spares. You've got 3 spares to go through. Let's say you get water damage in the vehicle and one of the wires goes bad. Then you have spare wires. So you need what if I'm doing a bus, you know, or a van or whatever, and I've got wire that's already run, and I know I'm going to panel the thing up, I'm never going to be able to go in there and put another wire in, right? I'm going to leave a few spare wires there, and I'm going to tag them on both ends. So one of the wires in where I have my fuse box, my distributor, it's basically the distribution box, which is a fuse box. One of the things that I'm going to do is I'm going to tag that wire and leave it in the fuse box, not connected to anything. I'm going to tag it, and then I'm going to tag the other end. These are spare wires, and I would tag them if they were all the same color. I'd tag them 1, 2, and 3. One on both sides, 2 and 2 on the other side, and so on. So I would leave a few spare wires just in case. So this is something that I haven't seen used. Whenever I'm watching the bus builds and the bus builds that I've watched, this is PVC. Okay, one of the things that PVC does is if you see the gray PVC, it's actually made for electrical, or just made for electrical wires. I don't know if there's any difference in the material, but gray, whenever you're working on a house, you know that the white is going to be for your water system. The gray, anything you see that's gray in there is going to be electrical. So generally is what you want is what you see is gray is electrical, white is water. But this PVC pipe can be cut in half. It can be cut in a quarter so that it would fit, so that it would actually fit in a corner. You could take this and you could run this along the baseline of the bus, or even on the side of the bus, if you in long pieces that can be taken apart, right? So that if you ever needed wire to go to the back of the bus, you could take a fish tape, or you could take something that, or even leave a spare string in there to pull another wire just in case you ever needed another wire. You never know. What if I'm going to put a light bar in the back of the truck? You know, on the back of the bus or the back of the van. You know, if I have wires there, then that possibility exists. But if I panel everything up and all the wire is hidden, you're thinking, am I really going to go through the trouble? Because you know how much trouble if you built this stuff, you know how much trouble, especially tongue and groove paneling and stuff like that is how difficult it is to put up. It's going to be just as equally difficult to take down and to rerun wire. That if you just had a simple, if I cut a corner like a 45-degree right here out of this pipe, I mean, that would leave me, about that much room, right? And I could run a fish tape through there and pull an extra wire if I needed one. However, if you leave those 3 wires there that I'm talking about, 2, 3 wires that I'm talking about, and you need that wire for that light or for that power, then you don't have to worry about it. Just leave access to it at the end of the bus and have the access at wherever your fuse box is, your distributor box. Leave that wire there. Mark both ends, and you have that wire there. But this is something that I haven't seen used in any builds that I know of. I haven't seen it anyways. But you could take this and make a space coming down from the roof, especially if you have a closet there. You could bring that down from the roof, and you could just push your wires through there to wherever they're going to go. If you're making a wall, you can put them inside the wall, that type of thing right there. But this will protect the wire so that it won't get damaged, and you also know where the wire is run, so you can visibly see, hey, even though this thing's painted, you know that you can see that rounded part there. And nobody would ever really know, if it's done correctly, nobody would ever really know that it wasn't just part of the bus, or if it wasn't a nicety, some kind of trim piece, that type of thing. But this is inexpensive, can be utilized. I haven't seen anybody use it, but I'm letting you know that, hey, that's a good way to protect wires. It's a good way to keep from damaging wires, and it also can provide you with a path if you ever need to add a wire. You could literally take PVC and go all the way from the front part of the bus down back to the back part of the bus underneath the bed, and put that, just cut it lengthways in a 45 so that you can fit it right in the corner. And you can get bigger ones than this too, so it doesn't have to be this size. You know, if that's not enough room for all your wires that are going through, you can get a little bit bigger. I think this is a 1.5 inch. So is what this is. 1.5 inch in diameter. So you can get this in 2-3 inches, that type of thing. And just cut it, stick it on the bottom, back behind everything, and you can just run that. And if you ever need to run a wire, or you have a bad wire that goes bad, you could actually just take that wire, remove it, and put a new wire in. So this is something that I haven't seen used. It is something that we've used in our electrical work, you know, that type of thing, and it can be used in a lot of different ways on that. But PVC's a good thing to do that, to run your wire. If you were running it, the other trick that I just mentioned is, hey, if you're building a closet, run your wires down the closet. There's nothing better or maybe not nothing better, but there's the use of a closet, especially in houses and stuff, when you're running wires after something's been built, is just a great way of running wires. So if you wanted to make your controls in your inverter, solar panels and everything, where you could get to them, you could build it into the back of the closet, run your piping into that closet if you wanted to. If you're going to use 3/4 inch board for your walling, right, which I've seen done before. If you're going to actually make a wall with space in it, then you could run them inside the wall. But you could run that from the top of the bus or van for your solar panels, and just run it straight down that tube. It's always protected. You know how to get to it, and then you can mount your equipment in that back wall. Put a cover over that, and then use it as a closet. Hang your clothes in front of it if you ever need to get to it. You just make a door, pull out the clothes, open the door, and there you are. You've got that. You've got access to that. Hey, there is one meter that I didn't mention, and that is your typical analog meter. You can do the same thing with this one. You just set it to, right now this one has a 1K ohm or 1000 ohm part of the meter. If you put that, you see the meter right there. See, it pegs to the farthest edge. So whenever you're doing this, it's a 1000 ohm, 1000 K ohm or 2000 K ohm on this. You're just looking for that line, the line to move all the way over to the edge whenever you're doing your ohms continuity test on there. So if you put that together on the, if you stick it on the wire and you get anything in between the 0 and the all the way over to the other side, then you know there's a problem with it. But generally, whenever you're testing the wires, you should just touch those two wires and get the get that to go all the way over to the right, which tells you that it has continuity. And then you want to open the wire or undo the wire at the other end, test it again, make sure you're not getting continuity, because if you are with those two wires separated, then you know that they are touching somewhere along the line. Thank you for watching this video. Please like, subscribe, comment, and next video we are going to be talking about the electrical system in the bus, cars, automobiles of any type, and I'm going to go over just the basics with you. These videos are going to be basic because I want people that have no knowledge of electronics and no knowledge of their vehicles. They're working on these things. They haven't ever done it before, and I just want these to be really simple so that they can get useful information for them to use when they are working on their projects. So you guys have a great day. We'll see you next time.